So this video focuses on the appendix to Chapter 4, which really is looking at figuring out money demand and central bank money demand when people hold some of their money in currency and some of their money in checking accounts. It looks a little complicated, it sounds a little complicated, but really it's not that complicated because we're just splitting that money demand by some assumed fraction, which we're going to call little c. So you have some money in currency, some money in your checking account, and then it all works out fairly well. So let's think about this. So we start off with our main money demand equation, right? Money demand is equal to nominal GDP times the liquidity function, so we get our downward sloping money demand. And we're going to make an assumption that people hold some fraction of their money in currency, C, so dollars, bills, and the rest is 1 minus C in their checking accounts, right? So C is some value between 0 and 1. Could be a half, could be a quarter, could be 3/4, whatever it is. So then we get our demand for currency, CUD, is equal to C times MD, and our demand for checking accounts is capital D, equals 1 minus C times MD. And so we've just taken our total money demand and broken it up into two pieces, right? Our demand for currency and our demand for money. And that's going to depend on, how easy is it to pay for things, with your debit card, how much do people like having cash versus having, not having cash. For instance, compared to the United States, in Japan, you hold a lot more cash than you do in the United States. So their C would be higher than the United States C. So, all right, so we've got demand for our checkable deposits. That means that's going to lead to demand for reserves. We have demand for currency, and both of the demand for reserves and the demand for currency are the demand for central bank money or monetary base or high-powered money, because that is what's included. And then that has to equal our supply of central bank money, right? So this is H. And so if we put our equations on it, remember demand for money is nominal GDP times the liquidity function. Our demand for checkable deposits is 1 minus C times MD. And then our demand for reserves is just going to be theta. That's that reserve ratio, which is usually around 10%, depending on the bank, times 1 minus C times MD. And the demand for currency is C times MD. So now we have to take those two pieces, our C times MD and our theta times 1 minus C times MD, and add them together to get our demand for central bank money. So putting it all together, it seems complicated. It's just some algebra. C plus theta times 1 minus C times our total money demand, nominal GDP times the liquidity function, has to be equal to the supply of central bank money. So if we let R be our reserves for banks, D is the dollar amount of checkable deposits, and theta is the reserve ratio, then we need to, our reserves are equal to theta times D, and if we combine those two equations that we had before, our demand for reserves is theta times 1 minus C times MD, which is what we had in that chart. Demand for central bank money is currency plus demand for reserves, so that's C times MD plus theta times 1 minus C times MD. We factor out the MD, we get C plus theta times 1 minus C times MD, which is finally the demand for central bank money once we replace MD with our nominal GDP and the liquidity function, right? Now, we know central bank money demand has to be equal to central bank money supply, or high-powered money, or monetary base. And so that's how we get our H is equal to C plus theta times 1 minus C, all times nominal GDP times the liquidity function. So this is how we are going to determine our interest rate. And you can use this equation to see what would happen, if C changes, if nominal GDP changes, if the reserve ratio changes, how is that going to affect the demand for money supply, and how is that going to shift the high-powered money demand curve and therefore increase or decrease the interest rate.